Hey, so we're gonna get going on what you sent me for the final exam review. So I noticed that you've already kind of gone through it, but um, you said that you had some questions. So I'll execute it, or I'll work the problems my way, review them, and then you can hit me up based on what you think you need to ask beyond what I've done here. So we can FaceTime after you watch the video. So what I plan to do is I plan to do each problem as a video. I don't want it to be this long, drawn out episode, if you will. So, sorry. So I'll break it out into, I think there are 4 problems. Yeah, 4 problems. So it should be fairly quick and fairly easy to record and upload. So you'll pretty much see these back to back. All right, so let's get started with number 1. The first one is given that f of x is equal to x squared plus 4x plus 5. That's all divided by 7 times e to the 3x. So just me, in terms of looking at part C, I know that at some point we're going to have to take the derivative. But I prefer to do the product rule over the quotient rule. And the reason why I say that is because you have this quantity down here that because of the quotient rule, people really get their algebra messed up because you're squaring the quantity of the lower, or of the function of the derivative of the denominator, sorry. So the function of the denominator is the 7e to the 3x. So your teacher is trying to, or your instructor is trying to, like, I guess, play with you or trick you or try to get you to really understand your algebra. But when you use the product rule, you don't really have to go crazy over algebra. And you don't have to worry about squaring the actual function, which could possibly lead you into some errors because every function is different when you square it, right? Or it has different rules, right? So what I want to do here is remind you that if something's in the denominator and you want to throw it up in the numerator, all you have to do is change the sign of the exponent. That's one of the laws of the exponent. So I'm going to rewrite f of x as just a product of 2 functions rather than a quotient. So in this case, f of x is equal to 1/7. So assume that this whole quantity is 1. So that's how I get the 1/7. E to the negative 3x times the quantity x squared plus 4x plus 5. So in that respect, I don't have to use the quotient rule anymore, and I don't have to do a lot of algebra changes in terms of trying to simplify a fraction when I don't really need to. Because there would have been a lot of reduction that had to have happened, and all that algebra is going to get you all jacked up. So what you want to do is you want to avoid as much algebra as possible, and you can kind of go from there. So one of the things that I downloaded a calculator. I don't know if you can use calculators, but you can use it for the sake of looking at the function, right? And the reason why I tell you to do that is if you take a graph of the function, or if you look at the graph of the function, this can really take care of your part A, the domain of x. If you're unsure of how to get domain, the best thing to do is just take a graph of it. So in this case, we technically don't need to, but we'll put the function in just for the sake of proof. But for right now, so before we get started, domain is the set of all x values that can give you a real and defined y value. So if you plug in an x value and you get a real number back, then it's good, right? Or if you plug in a value and you get an undefined value, or you get a value that doesn't exist, then you have that x value does not belong in that set. Right? So one of the things about this function is that oh, it looks like crap. Sorry. So the domain, when you look at 1/7 e to the negative 3x, that domain is all reals. You can plug in any x value, and you're going to get an answer. You're going to get a y value, right? So this is going to be all reals. In the domain of x squared plus 4x plus 5, because it's a polynomial, actually it's a quadratic, that's also all reals. So because the exponential function allows all x values and the polynomial allows all x values, the product of those two functions would create a function that has use of all reals. So if you were to take a look at that, so let's graph it, y equals, I'm just going to use parentheses, 1/7 times e to the negative 3x times x squared plus 4x plus 5. And let's just do a standard window. Yeah, let's see what it looks like in here. Let's see. Okay, so let me change my window so you can see. So your x max, we'll go negative 10, 10. Let's go negative 5, negative, or 0, right? And then we'll go negative 5, I mean 5. All right, and now let's graph it. Let's see how it looks. So if you notice, because it's the exponential and it's the negative exponential, you're going to notice that it's going to approach the x-axis but never touch it. So we know that this value right here will always be greater than 0. It'll be strictly positive. Right? So this one may not be a really good graph. You'd have to actually like look at it from like, I guess, 2 to see the asymptotic behavior, whatever that means, right? To see the behavior as it approaches the x-axis. So right now it's going to be all reals. You can put in any x value, you can get a y value, right? So domain is all reals. F of 0, that's equal to plugging in 0 wherever you see an x. So that's 1/7 e to the negative 3 times 0. Negative 3 times 0 is 0, so that's e to the 0 times 0 squared plus 4 times 0 plus 5. So that's 1/7 times 1 times 5, and that's 5/7. So you actually have a point 0, 5/7. All right, so that's a point. The derivative, so again, using the product rule, we're going to find out what's going on here, right? So the first times the derivative of the second plus the second times the derivative of the first. That's how so even now, after I don't know how many years that I've been doing math, I always literally say it to myself as I perform the derivative, right? So it's the first times the derivative of the second plus the second times the derivative of the first. And that's how I always do it. I will always say it while I do it. So think of this as your f, think of this as your g, and then take care of the respective actions. So it's the first, which is 1/7 e to the negative 3x times the derivative of the second, which is x squared plus 4x plus 5, plus the second, x squared plus 4x plus 5, times the derivative of the first. And that's 1/7 e to the negative 3x. So when we look at that derivative, so we have the first, so we'll take care of the derivative, right? So f prime of x is equal to 1/7 e to the negative 3x. The derivative of x squared plus 4x plus 5, that's going to be 2x plus 4 plus the actual second function, 4x plus 5, x squared plus 4x plus 5, plus the derivative, or times the derivative of the first. So that's 1/7 e to the negative 3x. Because of the chain rule, I have to take care of taking the derivative of the actual exponent. So the derivative of negative 3x is equal to negative 3. So one of the things that I like about the product rule is that you can factor out, especially when it comes to exponentials. They're very easy, and then whatever you have left over is just going to be what's ever left over in terms of the polynomial, so that you can do easy computation. So all I'm going to do here is just factor out. Now what I want to factor out is the 1/7 e to the negative 3x. I'm going to factor it out. Why? Because I have one here, and I have one here, and I'm adding them. So I can factor them out, and then whatever's left over would be a multiplication to that. Right? So I have 1/7 e to the negative 3x. Now when I pull that out, what do I have here? What do I have left over? 2x plus 4. What else do I have left over? So right now, what I have left over is I have this and that. So in terms of looking at multiplication, I pull out the 1/7 e to the negative 3x, that's out here. But what I have left is negative 3 times this quantity right here. So I'm just going to say so now all I have to simplify is this polynomial right here. So this gives me 2x plus 4 minus 3x squared minus 12x minus 15. So what does that leave me with? 1/7 e to the negative 3x. And then I have, what do I have? Let's see. Negative 3x squared. I don't like that 2. I've been jacking up that 2. 3x squared. There we go. So I have negative 12 and 2, so that's minus 10x. I have negative 15 and 4, and that's minus 11. Because they're all negative, I'm going to pull out a negative sign. So I'll actually get negative 1/7 e to the negative 3x times the quantity 3x squared minus 10x, or I'm sorry, plus 10x plus 11. So if we go back, I'm not going to write that derivative up here, but it says determine the equation of the tangent line at x equals 0. So in order for you to find the equation of the tangent line, you need two things. You need a point on the function, derivative value at that point. So these are the two things that you need to answer this question. So we already have part one from, or the first condition from right here. Right, so we have this point. We have this point. Right, so what we need to calculate now is the slope of the tangent line, and that comes from the derivative value of that point being 0, x equals 0. So let's find out f prime of 0. Well, f prime of 0, we already took care of finding the derivative of f. So plug in a 0 wherever you see an x. So I have negative 1/7 times e to the 0, that's 1. And then I have 0 here, so I have 0 plus 0 plus 11. So the slope is negative 11 over 7. Now, if you have the ability to use your calculator, let's quit that and let's go home. You can, so I'm using the TI-84 Silver. I think it's a really, really good calculator. I think the TI-89 is way too much based on what class you have. So I would recommend that if you have a TI-83 or 84, it's perfectly fine to use. But you can hit the math button and then scroll down to what's called n derivative. So you can take a certain number of derivatives, and this is going to give me the numerical value at that function. So the function that I have is 1/7 times e to the negative 3x times x squared plus 4x plus 5 in terms of x at the point 0. And I get negative 1.57. So I know it's something over 7 because of that denominator. I mean, because of the terminating of this decimal right here. It just has that pattern of it being over 7. But let me take my value, negative 11 over 7. Let's see if I'm right. Boom! It's approximately the same. Right? So the reason why it varies a little bit different is because it's approximating using algorithms in the function of n derivative. But the actual true value, or the real value, is negative 11 over 7. The exact value, rather. So the equation of the tangent line, and I'm okay with leaving it like this. It's going to be y minus y0 is equal to the slope at 0. That's not good notation. That's not good notation either. I'll just put n. X minus x0, where this x0 and this y0 come from the point that we have right here, which is 0 and 5/7. So let's put the point 0, 5/7 here too, because you need these two. So your answer is y minus y0, so that's this value, 5 over 7, is equal to the slope, negative 11 over 7 times x minus 0. And actually, you can just simplify it. Negative 11 over 7x, take the 5/7 on the other side, plus 5/7. Right, so that's your work right here for the first problem. So I'm going to upload this one If you have any questions, hit me up. Well, I mean, we'll talk about it on FaceTime. We were planning to take a look at all these problems anyway. So watch it as many times as you need. Write down your questions, and then we can fill in the blanks when we FaceTime.